Yeah, whatever. But all right. So we're gonna talk about chain rule. A chain rule basically deal with derivative of a composite function. So I mean, a lot of you guys didn't do composite function, which was like the on the test there was a x plus h problem. Like you had to plug in x plus h. That's actually a composite function. So you're actually practicing doing composite function. Um, so back then we have a f of x and we have a g of x, and we ask you what's f of g of x. But now what I'm going to do today is I'm going to ask you if I have f of g of x, right? If today I have says, let's just say if I have f of g of x in this column, and I'll ask you what is f of x and what is g of x. So for example, I'm going to give you the first one, says y equal to 1 over x plus 1. And I'm going to ask you, says, okay, in this case, uh, this y is equal to, this f of g of x is equal to 1 over x plus 1. So what will be f of x and what will be a g of x in this case? Anyone?
That's a great question.
That's a great question. Okay, Kevin?
Would g of x be x plus 1 and f of x is 1 over x?
G of x is x plus 1, yep,
And f of x would be 1 over x?
1 over x. Now does that make sense? Because technically, can I replace this into here? Right? So it will be 1 over x plus 1. So that's called composite function. It's a function within the functions. You had to do that with the x plus h on your tests, right? We had to figure out what is the equation, right? But in this case is I'll give you the equation and ask you what is within what. Okay, so it's very, very, very interesting. So then y is equal to sine of 2x. So besides Kevin, can anybody else tell me what is the f of x and what is g of x in this case? Oh, I have one viewer. I don't know who that is. I should say hi to him. It's probably a senior skip days. Senior. And anybody know, so what is f of x and what is g of x?
F of x sine x and g of x 2x.
What does everybody else think? Sine of x and this is 2x? It makes sense, right? So you replace this into this x. Okay, this is very, very good. So that's next one. So y equal to, let's say, square root of 3 minus 2x squared. What will be the f of x and what will be the g of x? I'm going to say hi to him.
We could have f of x be like the square root of x, I think. And then g of x could equal 3 minus 2x squared, I think.
F of x is going to be what? Square root of x?
Yeah. And then g of x could be 3 minus 2x squared. I don't know if that's right.
3 minus 2x squared. Does everybody agree with that?
Can't you also do square root of 3 minus x and then g of x, just 2x squared?
I think it might be multiples to
Wait, hold on. You say square root of 3 minus 2,
No, square root of 3 minus x
3 minus x.
and then
Yeah, you
g
could
of
do that.
x
Yeah,
is
you could
2x
do
squared.
3
G of x is equal to what?
2x squared.
You could.
Hmm.
I think you can do that.
Yeah, you could have done that. Yeah. But we just want to see the function within the function in this case. But there, this is a little bit more into the on the detail side. So I prefer to be this. Next one, how about y equal to tangent square of x? What'd you say?
f of x is equal to x squared, and then g of x is equal to tangent x.
Okay. Now here's my question. Some people says, what if I put, so some people got confused on the first period. They say, what if I have f of x is tan of x and g of x equal to x squared? Is that any different?
Wait, can you say that again?
Yeah, I think.
They got a revert. They got this change. You're right actually. They says, but they say g of x is x squared and f of x equal to 10x.
That wouldn't work because it has to be tan squared.
Right. So those are the things that notation wise people get confused, right? People get confused this part. So they can confuse this tangent of square of x. What does that mean? This means tangent of x squared. But that also does not mean tangent of x squared. This is fundamentally different. Why? Imagine if it's pi over 4. If I plug in pi over 4, it'll be 10. In this case, it'll be tangent of pi over 4 squared, which is 1 square is 1. And this means the same thing because you're going to say tangent pi over 4. Tangent pi over 4 is 1. 1 square is going to be 1. But in this case are different because that becomes tangent of pi over 16, which is we don't know that part of unit circles. Does that make sense? So those are not related. So a lot of people kind of like misunderstand that, but that's okay. So what happened here is I'm gonna do is I'm gonna show you what the chain rule is like. For implicit purpose is I'm gonna give you in this term. So dy dx, this is an implicit definition, and I don't like this definition, but I'm gonna write it out anyway. Dy du times du dx. Some people are very good with math, they can understand this and it very intuitively. But this is the way I usually explain because it makes much more sense. Is if I take a derivative of f of g of x, and that's going to be f prime of g of x times g prime of x. Okay. So those are the things that it's going to be dealing with chain rule. Now, what does that mean? It's just like, I don't know if you guys have peeled onion before. It's gonna make your eyes like teary. But if you're peeling outside, right, they have layer within the layer within the layer within the layer within the layer. Or like a Russian doll. I don't know if you've seen Russian doll. Yeah, like you had to be careful. Like I can search things on Google and say I type in Russian doll and it come out something inappropriate. Because I actually looked it up before and it was like clicking, it was like come out, oh my goodness, what is this? And so don't do that. So I don't want to show you on there. But Russian doll is those things that is a toy within the toy within the toy within the toys. So you can like open up and they will keep on open up and they keep on. And they're very creepy, I think. The diagram is kind of creepy. In terms of Russian doll or in terms of lollipop, there's like outer layer is sour layer, sugar layer, and lollipop layer, the gum layer, right? So there's a layer inside. So basically, what you're gonna do is take a derivative of the outside, right? And the inside still there, it's still intact, and then take a derivative of the inside. Okay, so you see, I take a derivative of the outside, I keep the inside the same. And then I take a derivative of the inside. That's what is the problem. So now you say, okay, well, let's take a derivative of a function. Now, when do you use chain rule? Like when do you use chain rule? So, rule of thumb. By the way, a lot of people use rule of thumb, but nobody know where they come from. Does anybody knows where they come from? it's coming from actually a really bad thing. Now you're probably gonna look it up. It's actually interesting. This is a part of history that, yeah, you should not be proud of. But a lot of people say rule of thumb and they don't understand where they come from. I do it because kind of teach people about different things. But yeah, you should look it up. What does the rule of thumb mean? Where they come from. But anyway, so the rule of thumb says, well, at least for me, this is I establish this, is any parenthesis, any parenthesis with power other than 1. So for example, 2, 5, negative half, half. So any power other than 1, you should use chain rule. Now, chain rule is so powerful, it's most of the AP exam questions, when they talk about derivative, they always do it with chain rule because people forget something. People take a derivative inside, people forget certain things. So those are the things, please pay attention that you make sure you understand. So when you do, when do you use chain rule? Rule of thumb says any parenthesis with a power other than 1. Example, 2, 5, 1, negative 1 half, 1, 1/3. So what I mean by that is I can take a derivative of this function now. So f of x is equal to 3 minus 2x squared to the 23. Wait, 23 power, do I really want to expand 23 times, right? The idea is not to using 23 times. The idea is to see what functions within functions, okay? So in this case, what function is within what function here? Yes?
You got x to the 23rd and 3 minus 2x squared.
Yeah, so you see there's an outer function, right? You see there's an outer function right here, and there's an inner function. Do you see that? Okay, so what I'm gonna do is I'm gonna assume this whole thing as an x, right? Can I take a derivative of the x to the 23 power? What is that? 23 what? 23x to the power 22, right? So f prime of x is 23x to the 22. Does that make sense? But except I don't write down the x. I write down 3 minus 2x squared. Now I just take a derivative of the outer term. What I'm going to do is I'm going to take a derivative of the inner term. You know what people usually forget is that inner term, which is negative 4x. So then you can say that is negative 92x times 3 minus 2x squared to the 22 power. Very, very, very useful. Are we okay here? You're going to take a derivative of this one. 2 minus 8x to the 15. I want you to take a derivative of this. It's very easy to take derivative. Today's homework is very easy. Because derivative of the inside, derivative of 3 is going to be 0. Derivative of negative 2x squared is going to be negative 4x.
Oh, okay.
So after I take a derivative, what am I going to get, Daph?
Negative 120 times 2 minus 8x to the 14 power.
Yep, probably right. 15 times 2 minus ax to the 14 times negative ax, and that's how you get negative 120, right? Is that right?
Yeah, but it's times -8, I think.
I think that's before you took the derivative.
Oh yeah, times negative 8, you're right. Times negative 8. That's equal to 2 minus ax to the 14. Perfect. You guys did a better job than I did. Are we okay here? Now think about how do I take a derivative of this function? To the third roots of 3 minus 5x squared to the second. So how do I take a derivative of this function? I know you know. I want you to write down. Everybody should be able to do this. And once you're done, check with each other, see what they get. So we got a parenthesis, we got a radical. What's the best way to do this? Convert them, right? So can I convert them to a power? Katie, did not see that?
Yeah.
So what would be the power? 3 minus 5x squared to the which power? 2 over 3, right? So can I take a derivative of this? Is it the other power than 1? Yeah, if it's 1, then you just take a derivative inside. But if it's other power than the 1, then it's kind of careful. You gotta be 2/3 times 3 minus 5x squared to the negative 1/3 times negative 10x. Does that make sense? And that's equal to negative 20x over 3 over 3 minus 5x to the 1/3. And that's equal to negative 20x over 3 times cube root of 3 minus 5x squared. And this answer and this answer are both acceptable. If it's a radical, then I can convert a radical. So all you gotta do is convert to that. Can I go over one more question very quickly? So let's just say if I have y equal to negative 7 over 2x minus 3 to the third power. Now remember this question we talked about, constant on the top, avoid quotient rule. So how do I avoid quotient rule? Can I change that to 2x minus 3 to the negative 3? Does that make sense? Now I'll take a derivative. So then it's equal to negative 7 times negative 3 times 2x minus 3 to the negative 4. But don't forget the derivative inside, which is most people forget. So it'd be negative 21, negative negative 42 over 2x minus 3 to the 4th. And that's chain rule. Is that okay? It's pretty easy, right? This video for those senior who skipped my class.
Where did you get, why was it negative 42? Because, yeah, why would you get positive 42?
Oh yeah, you're right, positive.